Everything that is written on max execution time when searching for it on Google or YouTube is about increasing its configuration value. In this video, I will discuss why instead you should be thinking to decrease this value from its default of 30 seconds to a much lower value of say 5 or 10 seconds and instead explicitly handle the edge cases. Why decrease max execution time? The reason is simple. PHP runs applications with a fixed number of maximum parallel processes, and that means maximum number of parallel requests. If you have a few pages that take close to 30 seconds, they can clock up the number of free slots to process other, faster PHP requests, risking that some users will run into HTTP error 503 service unavailable errors. A high setting makes scaling your PHP application more complicated and unpredictable. Remember Twitter's failway in the early days, around 2010? Twitter ran a Ruby application, not PHP back then, but the fail whale was Twitter's equivalent of quickly stopping requests that take too long. GitHub still does this today and shows you the angry unicorn when a page is taking too long to load. But what if you have slow modules that take longer than 10 seconds? Just increase the max execution time in the application on a programmatic page-by-page basis. You can guard the parallel execution with one of the strategies explained in this video. Hi, I am Benjamin and I write PHP code for over 25 years. I'm one of the maintainers of the Doctrine ORM, have contributed to Symfony and many other libraries. I'm responsible for bringing attributes to PHP core and serve on the PHP Foundation Administration Board and help thousands of companies improve PHP performance with Tideways, a PHP profiler. Why is everyone looking to increase the max execution time? That's simple. A single slow page and you are at a crossroad. Just increase the max execution time configuration globally through PHP ini. This is really simple, requires no programming skills, and is just a simple line change and restart of the website. Or increase the max execution time in code for just that page that is failing. This requires some understanding of the software system and requires changes to the code and maybe even a deployment of that code base. Or the third variant is improve the page's performance so that is running faster and not reaching the max execution limit anymore. This is usually the most difficult approach and might not even be possible or practical when a module is not that important or not used that often. So it's easy to see why a lot of people are searching for increasing this max execution time, and this is usually the most suggested solution when running into max execution time errors in PHP. Let's discuss a few strategies to safely allow scripts with higher execution time. You can set max execution time for just a single or few pages. You can use multiple PHP FPM pools. You can implement locking or a waiting list in code, or you can offload work to a message queue. Let's look at each of the four ones individually. Setting higher max execution time for just a single or few pages requires little PHP programming skills and some understanding of the application. You need to know where to change the code to set this value based on user requests and different modules that are being loaded. A simple example would be to just change the setting directly in the code that you know is going to be running slower. In this example, there's a generate PDF action method on a class, and we know that is taking longer, so we are setting the max execution time to 60 seconds from maybe a default of 5 or 10 seconds that the application is running on. A more generic approach is to change a central file in your application and decide on the execution time value based on request information. For example, set the max execution time to 5 seconds, and then if it's a request to a URL in the admin, then increase the execution time further to 15 seconds. The second strategy to safely allow scripts with high execution time is to use multiple PHP FPM pools. In the PHP FPM configuration, you define two pools, we call them front-end and back-end here, with two different sockets. The front-end pool has a static pool configuration with a maximum of 50 children. This is the part of the application that serves a lot of traffic and requires the response times to be quite quick. The backend pool has its own socket and uses the on-demand strategy to create processes. Up to 5 of them are created at the same time, but once they reach an idle time of 10 seconds, PHP FPM will shut them down and not use the resources for them. On the Nginx side, we conditionally use one of the sockets based on the URL of the application. So in this case, if the request starts with admin, then we are using the PHP backend socket instead of the frontend socket. A third strategy to safely allow scripts with high execution time is to implement locking or a waiting list in your application code. Locking is the more simple strategy, and I will show it here because it restricts the use of a feature to a single user at the same time. We are using the Symfony lock component here, but you can use different locking mechanisms, for example with Redis or with Unix semaphores, which are available to you depending on your application architecture. Symfony lock component abstracts all the different backends, so this code here is usable for any kind of backend that you want. We are creating a lock for using a name, PDF create, and only a single user will be able to run the code after the lock is acquired. If the lock cannot be acquired, we are showing a waiting error page. For example, I am sorry, this module is currently being used. Please refresh the page in a few minutes. If the lock can be acquired, then we are generating the PDF and we are rendering it. Finally, independent of an error or no error being happening, we release the lock and the module is available again for the next user to be processed. Waiting queues and waiting lines are a bit harder to implement if you allow multiple people to use the module at the same time, but you want to restrict them to, let's say, 5. You can do that either using PHP FPM Pools, for example, and risking 503 errors, or you can implement a ticketing system manually. The fourth approach to safely allow scripts with high execution time is just to not have slow execution time in the front end, instead deferring and offloading this work to a message queue. Again, I'm showing this using Symfony component, the messenger component here. For this to work, we have to move all the code to a backend script. In this case here, we have a new class, generate PDF message handler, and it is processing all generated PDF message classes. The Symfony Messenger uses a concept that's called message bus. You could also have different libraries that call them queue or worker or something like that. The front-end script then calls the dispatch method, passing the generate PDF message payload, and your application can be configured in a way that now the process is running in the background. Going back to the examples I showed before of how this looks like from the process perspective, here we can see that the PDF generate request is handled in a worker and the web server can still process all the fast requests, achieving the highest possible throughput. This is the end of this video showing some strategies how to handle max execution time. As I said, I really recommend setting this value to a low value of 5 or 10 seconds to making sure that there's a high throughput possible in your application and no slow requests are blocking or the faster requests that might be more important to your success of an application. If you want to dive a little deeper into this topic, I have also written the blog post, What is the best value for max execution time in PHP, on our Tidebase blog. And you'll find a lot of the information that I posted here in more detail, including the code snippets for the different strategies. And you can start using them in your own application or build a solution for your application based on them.